going to do some more finals review here. This is for the two big topics from Module 8, right triangle trigonometry, and then special right triangles. So I'm going to start with the special right triangles and then come back. Okay, so special right triangles, we had two different kinds. We had the 45, 45, 90, okay, which the legs were congruent to each other. And the hypotenuse was whatever the leg was times the square root of 2. Okay? We also had the 30, 60, 90. Okay? Which had the short leg, the hypotenuse, and the long leg, which is x times the square root of 3. Here was the 60-degree angle. Here was the 30-degree angle. Okay. So let's go ahead and do these first three examples, and then we'll come back and add a couple more things for right triangle trig. So for this one, this is a 45, 45, 90. They want me to find these two missing sides. So they are giving me the hypotenuse. So the hypotenuse is equal to x root 2. So I'm going to set 6 equal to x root 2. We're going to solve this equation for x. So right now it's being multiplied by root 2. We are going to divide both sides by root 2. So 6 over root 2 is equal to x. And x and y are the same, but remember I cannot leave my answer like that. I have a square root in the bottom. We're going to rationalize and get rid of it. So I'm going to multiply the top and the bottom by square root of 2. So this becomes 6 times the square root of 2. Root 2 times root 2 is just a regular 2. And then 6 divided by 2, we could rewrite that as 3 times the square root of 2. So this is what x equals and what y equals, because those are the same. Okay? All right. This one is a 30, 60, 90. So the side they are giving me is equal to the hypotenuse, right? So they're giving me the hypotenuse, 16. So 16 is equal to 2 of the short leg. Now my short leg is y, so I'm going to set 16 equal to 2y. So to solve for y, we're going to divide both sides by 2. So we get 8 is equal to y. So if this is 8, right, to get the long leg, we take the short leg and multiply by root 3. So x is equal to 8 times the square root of 3. Okay, number 3. Another 30, 60, 90. The side they are giving me is the long leg, which is equal to the short leg times the square root of 3. So 12 is equal to y times the square root of 3. So again, to find the short leg, we're going to get y by itself. I'm going to divide both sides by root 3. So 12 over root 3 is equal to y. Now, again, I can't leave it like that, so I'm going to multiply both the top and the bottom by square root of 3. 12 times root 3 on the top. Root 3 times root 3 gives us a regular 3. And we can reduce that. 12 divided by 3 is 4. So we get 4 root 3 is equal to y. Now, to get the hypotenuse, we double the short leg. So x is equal to 2 times the short leg for root 3. Those numbers are both outside the radical, so we can multiply those. So x is equal to 8 root 3. Okay? All right, now we're going to add a couple more things on the notes. The last three examples are right triangle trig, where I'm not dealing with 45, 45, or 30, 60, 90. I guess technically we are in 4. Okay. 4 is kind of an exception. I might change the angle on that one, you guys, just to make more sense. Okay. So this is for right triangle trig. So we are going to use our favorite acronym, SOHCAHTOA. So remember, what that means, we are going to set up an equation every single time. We're going to pick a trig function, sine, cosine, or tangent, then the reference angle, and then it's going to equal a fraction. So, sine, we use theta a lot of times for the angle, is always opposite over hypotenuse. Cosine of our angle is equal to adjacent over hypotenuse. And then tangent is equal to opposite over adjacent. Okay, now this is what I'm going to set up every single time. Now, one other piece here is we are going to use inverses when finding angles. And remember what those are sine with that little -1 exponent, cosine with that little -1 exponent, or tangent. Okay? All right, so let's try that down here. Okay, I'm going to change this angle, you guys. Let's make this one be 32 degrees. So it's not a 30, 60, 90. Otherwise, I could use my special right triangles. Okay, so let's make that 32 degrees. All right, now this is my reference angle. Okay, so this is our theta, our reference angle. Okay, so I'm going to label my triangle, OAH. So here is my opposite side, my adjacent side, and my hypotenuse. They want me to find x, so I actually don't really care about y. Okay, I'm going to find x. So I want to use the one I am looking for and the one that I know. So A and H, if I go back to my acronym, A and H go with cosine. So I'm going to set up this equation right here. So cosine of our angle equals adjacent over hypotenuse. Okay? Now, when our variable's on the bottom of a fraction, we're going to get it out of the fraction first. So I've got x times cosine of 32 equals 12. Divide by cosine 32 to get x by itself. So we have x equals 12 divided by cosine 32. And then you guys, we are going to enter that in our calculator to get x. Okay, so I've got 12 divided by cosine of 32. And we get 14.15 approximately. Okay, number 5, we are finding an angle. So this is like my theta or my reference angle. Okay, that's our reference angle. Okay, so if I label my triangle, 8 would be opposite, we don't know the hypotenuse, and 20 is adjacent. So I don't want to use the one that's blank that I don't have anything for. So we want to use adjacent and opposite. O and A go with tangent. So this is the equation that I set up. So we have tangent of our angle, we don't know the angle, equals opposite over adjacent. Okay, so what I'm going to do, you guys, I need to get rid of tangent. So the opposite of tangent is tangent inverse. So we're going to take tangent inverse of both sides. Okay, so tangent inverse and tangent cancel. And we're left with x equals tangent inverse of 8 over 20. I type that into my calculator. Second tan to get tangent inverse, 8 divided by 20. Typically, we rounded these ones, you guys, to the nearest whole number for angles. So x is approximately 22 degrees. Okay, number 6, last one. Solve the triangle. So this is find all the missing pieces, okay? So we need to find the side UW. We need to find the side UV. And then we also need to find angle V. Okay, I'm going to find angle V because that one's really simple. I just subtract these two from 180. So measure of angle V is 180 minus 80 and 90, which I think gives us 10 degrees. So measure of angle V is 10 degrees. Okay. All right. You can write that in there. You're welcome to. I'm not going to because I want 80 to be my reference angle. So here's my opposite, adjacent, hypotenuse. I have to find both the adjacent and the hypotenuse. We're just going to do one at a time. So I'm going to start with A. All right, so I'm going to set up, because it's A and O, I'm going to do tangent, right? So tan of our angle equals opposite over adjacent. So we have 11 over A. Again, I got to multiply both sides by A. And then divide by tan 80. So I have A equals 11 divided by tan of 80. So type that in our calculator. So we've got, what was it, 11? Yep, 11 divided by tan of 80, 1.94. Okay, and our adjacent side was UW, so 1.94 for UW. UV, now I want to find the hypotenuse, so I'm going to switch it up. So I'm going to do hypotenuse and opposite, which is O and H is sine. So I'm going to do sine of our angle is opposite over hypotenuse, so we have 11 over H. Same thing, I'm going to multiply both sides by H and then divide by sine 80, so I'm going to get 11 divided by sine of 80 for H. Type that in. And we get 11.17, which is the same as side UV. So there's our 3 missing pieces. We found all 3. All right, guys, that's it for the Mod 8 review. Thanks for watching.